Well, hello everyone. Nice to meet you. My name is Juan Roos, and I'm the CEO of Digital Earth Solutions. I'm sure you remember, well, some of the huge oil spill accidents that have happened in the last couple of decades. You can surely remember the ones who are from Spain, the Prestige, Deepwater Horizon, very famous as well, and also more recent ones that keep on happening, like the one in Gibraltar a couple of months ago. And the terrible impact that these accidents have on the local environment, society, and economy. Still, up to 4.5 million tons of oil are spilled into the oceans every year. And in order to minimize that impact, it is essential that authorities go into the ocean to try to intercept and collect the spill before it spreads and reaches the coast. However, ocean dynamics are a very complicated problem, as they are highly influenced, you can imagine, by the effects of sea currents, winds, and tides. And while current modeling solutions incorporate all these as inputs to understand the movement of the spill on the ocean surface, the process is very complicated, takes a lot of time, and also requires skilled technicians on the user side. While they understand pretty well the chemical degradation of the oil by the effects of light and biological components, they fail to understand the movement of the spill, the trajectory. And of course, this is very important. If you have a spill in front of the coast, you want to know how do you have to react against it. Based on that, in Digital Earth Solutions, we have developed a unique software able to predict within few minutes and with high precision the spatial evolution of any oil spill in the world, making a forecast either of the future trajectory of the spill or back in time to find its origin. Like we said, current softwares are very complicated, very complex, and they lead to steep learning curves. And additionally, combining that manual setup with very long computation times, the whole process takes in the order of hours. In our case, we can deliver any simulation in less than 5 minutes, leading to simulation times up to 20 times faster than the current competitors. Here you can see an animation example of our software in which the customer sends us the initial location, date and time and spill amount, and within few minutes we can deliver the spatial evolution of any oil spill with a very intuitive animation, as you can see. However, what mostly stands out from our solution is its accuracy. We have been studying for more than 20 years ocean dynamics at the Spanish National Research Council, and with a model that later became a software, we were able to analyze and published in very renowned magazines several real spill scenarios. And in all of them, the accuracy of our solution has outperformed the ones of the solutions used on the site of the accident. And that is also why we decided to create this spin-off. With all these benefits, we believe we can reduce, by using our software to make a more efficient approach towards collecting the spill, we can lower gathering costs, environmental impact, and socioeconomic impact, and therefore generate a saving up of cost of up to 50% when using our software. Our business model, as you can see, is initially we are contacting environmental consultants. They are our early adopters, as they are very keen to deliver the latest know-how to their customers, who are oil and gas and maritime transportation companies as the main responsibles of the spill, as well as the insurance companies who cover them, obviously. And by 2024, we plan to access the emergency cleanup services, who are generally public entities who are in charge of collecting the spills. And in this way, accessing a $4 billion market in the process. However, this doesn't end at oil spills. We can track any floating object that can be modeled with our software. This means that we can not only study oil spills, but also plastic waste, as it was proven by a project run last year in Galicia, northern Spain, human bodies, as it is proven with active collaboration this past summer with Spanish authorities in rescue and shipwreck situations, and other objects such as containers, algae, and gliders. However, we have been talking, yes, our model is amazing, we say it's faster, we say it's more accurate, all that, but what happens with the inputs? We say we need sea currents, winds, and tides to run the simulations. Where does this data come from? Well, actually, most of the software is also ours. We take the information from public entities such as Copernicus, and they deliver some kind of prehistoric data and 3-day ahead forecast, some kind of imaginary grid that you paint on top of the ocean surface. And of course, on the vertices, you get the information of the currents, the winds, and the temperatures and the salinity that we need to study the evolution of the spill. However, these have a limited precision. For example, the global model is 8 kilometers, Mediterranean 2 kilometers. And while this is fine for deep sea situations, you can imagine that at a port scale, well, this is not enough, the precision is not enough. So you need higher definition grids to actually profit from accurate modeling. Now, some institutions, for example, in Spain, we have Puertos del Estado, Rijkswaterstaat in the Netherlands, is they use their own data models with measurement buoys. And in this way, they can get the information that they need at higher precision. However, well, if you have to deploy this, it is very expensive. At Digital Earth Solutions, we are able to produce these local, high-definition hydrodynamic models without using any hardware. We just use a seabed bathymetry, the boundary conditions of the bigger model, and satellite validation. And as you can see for the Rafina port in Greece that we actually did last year for the European project called Impressive, we went from the 2-kilometer Mediterranean model to 20 meters. So, to finish this a little bit, we have on the one side the oil spill modeling companies, on the right-hand side, hydrodynamic data companies, but there is no one like us that is doing both right now. What is our unique value proposition is, okay, we are still an ocean modeling company with the benefits that we already told you about, precise prediction in spill motion, a user-friendly and at record speed, as we said, and a software that is accessible at any platform and any geography. But how do we convince those dedicated areas such as sports, protected areas, where they need higher definition information to run the models? It doesn't matter that it's better, we need better inputs to that. Well, we can deliver local high HD models with unparalleled accuracy and tailored inputs and automated generation in 2-3 weeks. And in this way, we can attract and secure strategic allegiances, not only with a very good product, but also with very privileged inputs to our modeling software. Thank you very much for your attention. We're currently raising an 150K investment round, so if you would like to join us, well then please contact us. Thank you very much.